Let's go back to our old friends, necessary and sufficient. Our old friends, necessary and sufficient. Okay? Simple here. The first derivative of our function equal to 0. That's the necessary condition. It has to be equal to 0 for us to find the min or the max. Has to be. Okay? But by itself, it might not be sufficient. It might be an inflection point. Okay? It might be that we're looking for the global whatever, right? Might not be. Sufficient is this plus the second derivative is negative for a max, and the second derivative is positive to find a minimum. Okay? So now we're going to be finding first derivatives and second derivatives. We're going to force the first derivative to be 0 to solve the equation. Then we're going to look at that second derivative and see what it is. And we hope that that second derivative is always negative or always positive. If it's fluctuating around, then we have to investigate a little more to see what's going on with our function. Okay? Is that exciting? You're like, no, it's not that exciting. Yes, it is that exciting. Okay? Because exciting. No? Okay, fine. So let's suppose we have a business, and here's our total revenue function. Okay? That's the total revenue function. That would mean we have a demand curve, yes, where price equals 32 minus Q. That would be the demand curve. And from this demand curve, we would have that total revenue function. Okay? So the first thing we do is find f prime x, or in this case f prime q, but f prime, first derivative. First derivative is 32 minus 2q. We set that equal to 0. That tells us that q equals 16. Okay? So that's the maximizing point, the optimizing point, actually. It might be a maximum, or it might actually be the minimum profit that we just found, or the minimum revenue. It's not, but it might be. We have to find the second derivative, and that means we take the derivative of this guy, and that's minus 2, which is always less than 0, right? Minus 2 is always less than 0. Therefore, this is a maximum. Okay? Is that exciting? You're like, yeah, well. Okay, fine. So that was maximizing revenue. We could also say, okay, we have a cost function, which is this. And usually our cost functions are cubic functions when we write them out, because that gives us, profit areas and loss areas and blah, 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 blah. No? Okay. Yeah, I can tell you're excited by that. No? Okay. So what I do with the cost function is I take my total cost and I divide it by Q. So I get Q squared minus 5Q plus 60. right? Yes? Okay. And I take the first derivative of that, and I'm going to get 2q minus 5. I'm going to set that equal to 0, and that would say q would be 2.5. And then I would take the second derivative, and I would get plus 2, right? The 2. That's always greater than 0, so I have just maximized this baby. Is that exciting? Okay. If I say profit, then I need a total revenue function and a total cost function. So maybe my total revenue function is this, and my total cost function is this. How do I maximize my profits? Well, I take total revenue and I subtract total cost. So there's a minus, right? Minus plus 140q plus 845. Okay? Yeah? So now I take the first derivative of that with respect to q. I get 5,900 minus 20q, right? Minus 6q squared plus 8q minus 140. Is that exciting? Yes? So I get minus 6q squared minus 12q plus 5760. Yes? 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 Minus 6q squared minus 12q plus 5760. We set that equal to 0. We have minus b plus or minus the square root of b squared minus 4ac over 2a. Yes? Minus b is 12. Plus or minus square root of minus 12 squared plus 4 times minus 4 times minus 6 times 5760 over 2 times minus 6. Okay? So that's 12 plus or minus 372 over 12. Yes? So that's 1 plus or minus 33. Right? So we have two answers. One is 34, and one is minus 32. Something like that. Unless I screwed that up. Oh, that's 31. I lied. 31. So it's 32 and minus 30. How's that? Okay? So we're not going to take minus 30. Yeah, we really don't want minus 30 as our profit. So if you have a business and you can sell 32 items or you can sell minus 30 items, which are you going to sell? Yeah, you're not going to sell minus 30. I don't even know how to do that. Okay? So the answer is here 32. So Q equals 32 is max profit. Now we go back here and we say we have minus 6Q squared minus 12Q plus 5760 is our function, right? That's the first derivative. The second derivative is minus 12Q minus 12. Yes? Now, he said, if Q is always positive, then this is a minus minus a minus. That's always negative if Q is greater than 0, and therefore this would be a max. Okay? Yeah. Okay. All right. We got this? Hopefully we got this. We got a little bit of this. Okay. Necessary and sufficient. We want the first derivative of the function to be equal to 0. That's the necessary, right? Sometimes called the first order condition, which is necessary. And we want the second derivative to be less than 0, okay, which is the second order condition, which is sufficient. Now, what happens if f, the second derivative, equals 0? Okay. What if this is true? Then this thing is not a sufficient condition. It's another necessary condition. And what we do in that case, is we go looking for, we go looking for the next one. So we have these things, Maclaurin and Taylor series. And trust me, we are not going to spend time working on these because so most of you are going to go on and take another course in this, and you're going to do a lot of them kind of babies things when you get there. And at this point, it's kind of just a waste of your time. But the point of these is we have a way to expand things around a function, and we can start proving things about, we can start proving things about these sets of first derivative, second derivative, third derivative, fourth derivative, fifth derivative. So what we do, just remember this. If the second derivative is 0, we keep taking more. We'll take the third derivative and the fourth derivative and the fifth derivative, or however many derivatives. We find the first non-zero derivative. It could be the third, the fourth, the fifth, the sixth, the 12th, the 82nd. Assuming there is one, we search for that one. Okay? If it's a max, two things are going to be true. For it to be a max, two things are going to be true. It's going to be negative, and it has to be an even number. So 2, 4, 6, 8, 10, 12. I need both of those to be true for it to be a max. For it to be a min, it has to be positive, and it has to be an odd number. No, I'm screwing that up. Still has to be an even number, all right? So it's got to be a 2, a 4, a 6, an 8, a 10, but a positive, and then an inflection point if it's odd. If the first non-zero derivative is the third or the fifth or the seventh or ninth, okay, then it's an inflection point. So I was way ahead of myself here. Ignore that. So if it's one of the even derivatives, then negative for a max, positive for a min. Just like the second derivative is an even derivative, negative for a max, positive for a min. If the first non-zero derivative is one of the odd derivatives, the 3, the 5, then it's an inflection point. Okay? And you might actually have the case where it doesn't matter what derivative you take, it's always 0. And then, yeah, then we got nothing. Okay?